Hello and welcome to Teen Academy question 5. Today we have a question about a snail. A gardener finding snails within his garden, and it can be modeled by a Poisson distribution. For the first question, we're asked to suggest two observations of the gardener. This model may lead the gardener to suggest. I will list two and then mention the others. First off, that the slugs either appear here discretely, independently, in depth, or randomly. This is at or that they appear at a constant rate. That the mean, the approximate mean approximates the variance. Okay, so that's question A. Now for question B, it says find the probability that the gardener finds exactly 4 snails in his 12-meter garden, and we know that the mean is equal to 0.2 snails per meter squared. Okay, so and for question B, the probability, B is P that he finds 4 snails. P of equal to 4 snails. Okay, and we know, again, that the mean is equal to 0.2. Okay, so inspecting a 12-meter garden, we can simply find our new mean, nu mu, which is equal to the 12 meters squared multiplied by 0.2 per meter squared. Okay, so our new mean will come out to be 2.4. And so, therefore, our x value for the probability, our Poisson distribution of 2.4 is about P of x is equal to 4, then becomes approximately 0.125, where the more exact answer is 0.12548 when we look at our table for our mean. Okay, so, and here we have, of course, used our Poisson distribution function, our PDF, to find our answer, and we will do so for other questions as well, such as C and some others. Anyhow, so for question C, the question asks, find the probability that in 3 consecutive inspections, the gardener finds at least 1 snail. So when we say, yes, oh, nope, okay, skip the question. Question C, sorry. It's find the probability that the gardener finds fewer than 3 snails. Okay? So that means we can either find the probability that are in our distribution function for x less than 3 or less than or equal to 2. Okay? And if we look at our probability distribution function, our answer would come out to be 0.569708, which is approximately just 0.570. Okay? And now for question D, we're looking at the probability that in 3 consecutive inspections, the gardener finds at least 1 snail per inspection. Okay? So for question D, at least 1. Oh. So that means at least 1 is greater than or equal to 1. And then when we look at our PDF, yes, then we find that our answer is 0.909282. And then if we raise to the third power for the 3 inspections, for the sake of the 3 inspections, we will find our final answer. Okay, which comes out to be 0.7517517888, which we can approximate to be 0.752. Okay, now for our final test, we are asked to state the hypothesis for our test, and then we are asked to find the critical region test at 1% significance level for question F. And then for question G, we were asked, given the mean number of snails has actually risen. Okay, that's kind of different. Okay, so for question E, we're asked to state our hypothesis tests. Okay? So, for the hypothesis test, we have our H naught, which is, of course, 2.4, yep, which is our new mean with our 12-meter garden. And for H1, the mean is greater than 2.4. Okay, so this is our hypothesis test. This is what we would be investigating. And for question F, we're asked to find the critical region. Critical region at 1% significance. So to do this, we either find the probability for a function greater than or equal to 7, or greater than or equal to 8. Okay? Now this is one of our options. Our other option is to find our function greater than or equal to 7 or greater than or equal to 6. Okay, where each of the values within our function respectively are equal to 0.01160, 0.00334, 0.01160, of course, and equal to 0.988405, okay? And then from here, the critical region is either either x greater than or equal to 8 or x greater than 7. It can be found at these values. Okay? And for our last question, we're asked to find, given that the number of snails has rose per meter squared, has rose to 0.75, find the probability that the gardener will make a type 2 error. So I guess that'd be the frequency. Yeah. So 0.75 per meter squared. P of type 2 error. Well, now what we're searching for our 12 meter squared garden. We multiply the new frequency by the 12 meter square garden, and we can find the probability for a type 2 error by looking at our probability distribution function for the following, and our answer will come out to be 0.324. And that's all for this question today.